In this video, we're going to look at Chapter 1, Section A on number sets. Now, a number set is really just a collection of objects or things. For example, if we take a look at the collection of vowels in the English language, we see that they're just a collection of these letters A, E, I, O, and U. And using appropriate mathematical notation, if we put brackets on either end of that collection, we have a number set. And we can abbreviate that number set as the capital letter V. Another example would be to look at all the even numbers, all the even real numbers. And those would be 2, 4, 6, 8, so on and so on, all the way to infinity. So a few important terms here. The vowels are an example of a finite set because there are only five elements in this set. Even numbers are an example of an infinite set because we could never list all of the even numbers in the real set of numbers. Another common notation that we see when we're talking about number sets is this guy right here, and this means is a member of. So looking at the vowels, we see that A is a member of the vowel set V. Likewise, this symbol means is not a member of. So the example using the even set, 3 would not be a member of the set E. So I have a few more definitions for you. We're going to define the natural set of numbers as all the counting numbers, including 0. So 0, 1, 2, 3, 4, and so on to infinity. And we're going to designate the natural set of numbers with the capital letter N. The integers, which we'll designate with the capital letter Z, are all the counting numbers and their negatives. So 0, plus or minus 1, plus or minus 2, and so on. Now if we want to designate just the positive integers, we can add a plus sign here, and obviously the set would only include the positives of the integers. The rational numbers we designate with the capital letter Q. And remember, rational numbers are any numbers that can be written in the form P over Q, where both P and Q are integers. So these are decimals that repeat, or decimals that end, or whole numbers. Irrational numbers have decimals that go on to infinity and never repeat. So an example of an irrational number would be pi. It can't be written in the form P over Q. And then the last set that we're going to deal with is the real number set, and we'll designate those with the capital letter R. And real numbers are any numbers that can be placed on a number line, right? So anything that can be placed on a number line. And real numbers include natural, integers, rational, and irrational numbers, right? So I know that pi is an irrational number, but pi still falls on the number line right around here. So it's a real number. So now we're going to do one quick example problem. And what you're being asked to do is to show that 0.36 repeating is a rational number. So we want to see if 0.36 is a member of the rational numbers. And remember, rational numbers can be written as P over Q, where P and Q are integers. First, let's set x equal to 0.36 repeating, which we know is equal to 0.363636 on into infinity. Now, if we multiply both sides of that equation by 100, we have 100x equals 36.363636 repeating, or 36 plus x. Because notice that this chunk right here is equal to this chunk right here, which is x. So now I have an equation, 100x equals 36 plus x. I can simplify by subtracting x on both sides. I have 99x equals 36. Therefore, x is equal to 36 over 99, which is equal to 4 over 11. 4 and 11 are both integers, therefore 0.36 repeating, or x, is a rational number.